Is Keith Simons. You are principal scientist at SHV Energy, a huge company, and you will learn us about biogas futures in transport. A promising title.
Thanks very much, Anders. So just to start off, you did mention that we're at the front of the peloton. Sadly, those days are behind me. But we've got Katrine, Patrick and Per that are at the front of the peloton, my colleagues in the audience. I'm just the support vehicle, driving ahead with the beers and the sandwiches. So the title of my talk is Biogas Futures in Transport. Just to be more specific, and more specific to our company, we see that as being Bioenergy and in the future Bioenergy. So a little bit about SH3 Energy. We probably are the largest company you've never heard of. But here you will know us by various brand names. So here in Scandinavia, the group has got Macro, Erics, various diversified companies. We're about 20 billion euro turnover, 60,000 employees. But as SH3 Energy, you will know us here in Scandinavia as Primagas, in the UK as Caligas. Though we are global, we're all over the world, though known as different brand names. Originally, back in 1896, we were coal traders. So taking the coal from the Ruhr Valley in Germany, trading that down the Rhine into the Netherlands, and from that grew to the diversified industrial company that we are now. In the 1950s, got out of coal, got into LPG. We've got a small biomass business. More recently, we've got into LNG, and then now biopropane, bio-LPG is our new business. And the future will be decided, hopefully in partnership with some of the people in this room, as to our future energy products. So, we've got a very bold ambition. We are a traditional distributor of fossil fuels, though by 2040 we have set the ambition that we will be ready for the Swedish 2045 target, that we will be sourcing, all our energy products from renewable sources. So this will be a huge transformation for the company. And to put it into perspective, at the moment, we deliver about 5 million tonnes of LPG directly to our customers. We trade another 5 million tonnes. So that's a big transition that we're going to be making over the course of the next 20 years. And it's going to come from advancements in technology and science that will come from partnership with hopefully some of the people in this room. So, is there a future for bioenergy and bio-LPG in transport? Quite often we hear it said, well, the future's electricity. We're going to transition to renewable electricity. Though, of course, depending where you are in the world, not all electricity actually is renewable. There's still quite a high fossil content. But if we look at, of course, liquid fuels, can address all of the transportation needs. But thinking about electricity, yes, perfectly feasible for short domestic travel. Long distance travel, yes, bigger batteries, charging stations, viable. Railways, electrification's been around for many years. Buses, of course, going back to base, they can be electric. But the challenge then comes as to, delivery trucks, aviation and shipping. And there we would argue that, probably with the exception of aviation, then, gases can address all of those needs. And I'll talk a little bit about how we're going to achieve that and work in symbiosis with other industries. So, Bioenergy and Bio-CNG. There is a growth in LNG and CNG around Europe. Here's some data I pulled of the NGVA website a couple of nights ago. So on the left we see these are the various LNG filling stations which are developing across Europe. There's more CNG stations. So there is the opportunity, of course, to transition these to the bio equivalent. It varies an awful lot across Europe, largely dependent on the incentives. But the original roadmaps had all of the long distance transportation with LNG, and here you see the developments of that across certain countries. Now, of course, coming back to electric vehicle growth and CNG growth, these are the new registrations from, I think it was 2018. And although there is a large growth in battery electric vehicles, again, 1-2% growth, slightly smaller growth, but relative to electric vehicles, it's still slightly less, slightly niche, but there's still a substantial growth in, sort of new passenger vehicle registrations. And has been said this morning, they will exist over the next 20 years as well. But yeah, let's go back to the origins. Where is the feedstock? Where is the biogas going to come from? So there's a lot of biogas production in Europe, led very much by Germany and then Italy, and then sort of agricultural nations, sort of decreasing. So most of that at the moment is for power generation. Then a little bit less, as we'll see in this slide, is injected into the grid because you need to clean up the gas. So going from biogas to biomethane, of course, you need to separate out the methane and the CO2. Most of that CO2 is vented. We heard this morning about the challenges of liquefying the CO2, but quite often it's too small a scale for those investments. So what's interesting across Europe is that a lot of that biomethane, once it's cleaned up, is injected into the grid. The exception being Sweden. You've got other uses for it here. But clearly growth and even more growth potential. So the European Biogas Association and the World Biogas Association are looking for huge growth to satisfy some of the decarbonisation needs within Europe. So potentially, up to 15% or sort of 13-15% biogas will be converted into biomethane to satisfy energy needs. But I do believe that there's opportunities to go further, and I'm delighted to hear of the developments at ST1 where looking at how to valorise that CO2. In the future, we hear about the hydrogen economy where there will be, sort of a lot of hydrogen. But hydrogen's a great clean fuel, but it's terrible to transport. The energy density is terrible. Even when we hear about hydrogen being injected into the grid, you can go up to 20%. That's 20% by volume, 3% by energy. And that's the thing that people forget. Quite often we have an awful lot of rural customers off-grid, and we've heard politicians say, well, instead of an LPG tank, there's going to be a hydrogen tank. We'd be there every other week trying to deliver that hydrogen, and in the winter, we only have so many trucks and people would be cold in the winter. So we need to look at how we can actually valorise the hydrogen as and when more comes on stream, and biogas, the CO2, converting that into methane is an excellent way just of storing that energy. And if you go into the poster session, I was delighted to see a poster from Norway sort of talking about this work, and I'm delighted that we heard about it this morning as well. So alternatively, there are microbial fuel cells that we can look at. So I think there's going to be huge growth there. At the end of the day, I love CO2. It's a great feedstock. And then there's an awful lot of talk about, direct air capture, there, the second law of thermodynamics gets in the way. If you've got CO2 in a relatively pure form at high point source, then use it where you can. So that's sort of where we see the future of bioenergy based on growing our still nascent LNG business. But bioLPG is where we come in now. So we've got some people here from Neste. Very grateful that your byproducts from your HVO process is biopropane. And then, as we mentioned, announced a couple of years ago, that bioLPG from the Neste Rotterdam plant is being distributed throughout Europe in our businesses. At the moment, about 40,000 tonnes from that Rotterdam plant, though we've got the ambition to grow that. It's a drop-in replacement. I can't emphasise how important that is from both our infrastructure and the customer infrastructure. So the only difference is in the manufacturing route. So whether it's from the import terminals, the trunk carriers, the mini carriers, the cylinders, the filling stations, there are absolutely no changes to our infrastructure, and the customer sees no difference apart from the fact that they've got a decarbonised energy solution. So very much important, whether it's in forklift trucks or London taxis, decarbonised solutions where there's little change, little additional upfront cost for the customers will be crucial. We talk an awful lot about decarbonised solutions for the customers. Fuel poverty is something which never really gets mentioned. Those high costs up front which will affect people. So BioLPG, it's available now, and we use a variety of different feedstocks, or Neste for us used a variety of different feedstocks, mainly to make hydrotreated vegetable oil, used very much in the Nordics here, and then the byproduct from that, from the triglyceride hydrotreatment, is propane, and then we distribute that to our customers. As well as the relationship with Neste, we're also investing in the future and then working together with the aviation industry. So you may have seen an announcement that was signed earlier this year that a future Sky Energy plant together with KLM will be making sustainable aviation fuel, and there'll be about 15,000 tonnes a year of bioLPG coming from that plant to satisfy our customers. Now, one of the things which as a scientist I find fascinating is that most people have tried to avoid making our product for the last 100 years. If you talk to people in Fischer-Tropsch, then they try to make wax and avoid making the C2, C3, C4 hydrocarbons. They're always quite puzzled and amazed that I really want the light hydrocarbons. But there's a whole range of different technologies and approaches that have been looked at. This is just one snapshot, but generally people have avoided looking at research. So for me it's been fascinating looking at this, researching this, in partnership with other universities. We don't have a R&D department internally, we work in partnership, and I'm glad that one of those partners, Jude from Aston, is here today, who's looking at different routes to make bioLPG for us, and we are looking for more partnerships, so please do get in touch. At the end of the day, the challenge is that most of the processes you'll find bioLPG is a byproduct of someone else's process. So there is low conversion selectivity to bioLPG. Of course, there are then limited feedstocks. Our holy grail up there, of course, is there would be high feedstock potential and then high selectivity to bioLPG. So I'm very much interested in working with the best academic research base. So a lot of that's represented in this room to look at on-purpose bioLPG manufacture. We do fund. So my preferred model is that if someone's got an idea, we'll fund a feasibility study looking at that, and then of course as we go up in the complexity, when we show promise, the amounts of money that we know we have to spend will increase. And then, of course, if we're successful, my colleague Katrina's got to find me €1 billion so we can build the plant. So I'm looking forward to that conversation. One of the things, so this is all in the production side, but one of the big challenges is the delivery vehicle, the last mile. So here is a project that colleagues of mine in Biogas in the UK have been involved in, and that's our own delivery truck. So, of course, bottom left, you'll see our cylinder delivery truck, about 16-ton vehicle that normally you wouldn't be able to convert to electric. However, working with EMOS in the Netherlands, what we've been doing is developing a hybrid LPG or LNG in the future engine. So with that, we have military-grade lithium-ion batteries. They charge up overnight in the depot. We load the cylinders up into that lorry, and then it goes off out into the road, and then as soon as the battery falls below a certain limit, a 2-litre LPG engine charges the batteries. So it doesn't charge the drive shaft, it charges the batteries. So we go from having a 40-mile electric range to a 250-mile range, extended range. And then as soon as we get into the delivery zone, if it's a low emission zone area, so like in London, soon to be Birmingham, we can switch off that LPG engine. The big advantage here is that normally in a truck like this you'd expect a 5-litre diesel engine. We've got a 2-litre LPG engine, which is the same as goes into a taxi in London. So it's all standard equipment. And of course it's cleaner, quieter and lower carbon. So on a well-to-wheels basis, we've got, sort of 82% saving. NOx is, sort of virtually, and PM's virtually eliminated. And then, of course, in geocached areas, it's very low indeed. And finally, the sky is not the limit. So there is a Danish entrepreneur who has worked in partnership with the UK government and established a UK-based company, and he's going to use propane and Calagas's biopropane as his launch fuel. What's quite clever is it's been known for quite a long time that propane has the right impulse characteristics for space launch. But if you want low Earth orbit, then the innovation of Orbex is they've got a carbon fibre tank where you put your propane in and the liquefied oxygen around it. So you only need a thin inner tank, which reduces the weight. So you can, I think it's 150 kilo payload, 500 kilometres into the air from, sort of Sutherland in Scotland. Is going to be launched using biopropane as the fuel. The reason they use biopropane is the government said for the license to do space launches, you need to achieve, good environmental standards, and they're achieving that with our biopropane. So the great thing about this is I can now tell my daughter, Dad is a rocket scientist. So, again, I am looking for partners, and please, I forgot my business card, but make a note of my email address, and sort of, if you've got ideas on how to do on-purpose bioLPG manufacture, please get in touch. Thank you.
Thank you, Keith. You ended with kind of futuristic slides.
2021.